Hi guys, the point of this tutorial is to help get you ready to be able to answer word problems involving speed, velocity, and acceleration. To do this, you're going to need to use formulas that I will give you. I'll always provide you with a cheat sheet with the formulas on them, or I'll write them on the board or something like that. So you don't have to memorize any formulas, but you have to know how to use them in word problems. So to get us started, what I want you to do is just try this word problem on your own. Pause the tutorial, grab a piece of loose leaf, and try this out and see what answer you get. Then, after you get your answer, come back and check to see how your answer and mine compare. Okay, let's assume that you've done that. You've gone ahead and you've done the problem. Here's what I'm looking for you to do on a problem like this. So if I had a quiz question, this is what I would be grading you on. Not just the answer, which I have in a box right here, but all the work and the units and where you rounded to. All of those things are going to be graded. So let's say that this question was worth a total of 4 points. To get 4 out of 4 points, you would need to have written the formula, that's 1 point, shown the substitutions you made of the numbers for the letters with the units, which is going to give you a half point. You have to get the right number answer, 8.3, and it has to be rounded to the right number, which is 0.3, because your calculator will say 8.33 repeating, and you have to have the right units, that's a half point. So that gets you up to 4. 1, 2, 3, a half and a half is 4 points. So a lot of students who are really good at math find this annoying. Well, if I get 8.3, shouldn't I get 4 out of 4 points? Maybe you feel that way, but that's not what's actually going to happen on your quiz. So you need to make sure that you're following the format that I'm giving you. You have to do all these steps. Write the formula, write the substituted numbers with the units, write your boxed answer rounded to the right number with the right units shown. So let's go through how I accomplished all of that in this problem. So step 1 was that I wrote down what I was looking for. So the problem asks me, what is his speed? I just underlined that in blue. His speed is what I'm looking for, so that's how I know I want the speed formula. And the speed formula is distance divided by time. And I'm abbreviating distance and time and speed with their letters. So distance in this problem is 150 meters. So that's why I wrote 150 m. And the time was 18 seconds. When I put it in the calculator, like I said, the calculator gave me 150 divided by 18 is 8.333 repeating. So how do I decide what to round to? I'm going to give you a simple rule. Here's the rule. Sorry about that, guys, little interruption. Okay, so the rule is for rounding, what you want to do is you want to look at the numbers that you have in this step and ask yourself, which is the smaller number? And the smaller number is this one. It's got, when I say smaller, I mean how many digits it is. So it's got 2 digits. So I want my answer to have 2 digits in it. That's why I rounded to 8.3, because I want to have 2 digits. Not 2 decimal places, not a number that goes out to the tens place, but 2 digits, right? The top number has 3 digits, the bottom number has 2. So I'm going with 2 digits in my answer. This will usually give you the best rounding option. And then finally, I have to know what units I'm going to use. Now there's 2 ways that you can know what units to use. One is you can say, okay, speed is what I'm looking for, and I know that the units of speed that we use in this class are meters per second, but that may not always be true in the problem. The problem might not have meters and seconds. It might have kilometers and hours. So you have to think about what units did you actually use, which is why I had you write the units in here in the previous step. This should tell you that your units are meters per second, because look, it's meters divided by seconds in the problem. And that's what this little per sign means, right? It means divide by. So that's what it takes to get a problem like this correct. Let's practice. I'll give you another problem and then I'll show you my answer and you can compare. Okay, so try this problem on a piece of loose leaf. Try and follow the format that I gave you. Make sure you include all the parts so that if you were answering this on a quiz, you would get all the points. When you're done, come back and check to see how you did. Okay, all done? This one has some extra stuff going on. Here's the extra stuff in the middle. You actually have to add up the total distance and the total time. It didn't give it to you all as one number. So instead of, you could have just written that the total distance was 7 and the total time was 70, but before you did that, you had to at least do on your calculator or in your head this step. I would like you to write that step because it shows me how you get from one part to another. So you should definitely include it. So you had to write the formula, did you? You had to include this step, which a lot of people would probably leave out. And you had to show with your units what you divided by what, and then your answer would be kilometers per minute. 0.10 kilometers per minute. Let's try one more. Okay, try this one. Do it on loose leaf and then come back and check my work. What'd you get? Okay, this one, same deal. Speed is distance divided by time. That's my formula. I wrote it here. I plugged in my numbers, but watch. On the bottom, you notice how my time is 2.5 hours? How'd I get that? Well, there's 2 hours and 30 minutes. I can't do 2 hours and 30 minutes on the bottom. I have to either have my time in hours or in minutes. And you could do it either way. I just chose to change minutes into hours. So 30 minutes equals a half hour or 0.5 of an hour. I did my work for that over here. Some of you might be familiar with this method, but don't worry if you're not. You don't have to show the work for converting your hours into minutes or your minutes into hours, but you do have to get that part right to do this. And if you have trouble with that kind of thing, you might want to ask for help. So after I did that, I plugged it into my calculator, I did my division, I rounded to 2 places, right? Because I have 2 places in my bottom number, so I wanted 2 digits in this number. All right, I actually want to do one more because the next one on this sheet is actually a little bit tricky, so let's try that. Okay, check this one out. See if you can do this one, a plane's average speed, that one on the bottom there, and then come back and check your work with mine. Okay, let's see. So it's still speed equals distance over time. Here's the weird thing though. We're not looking for speed. So when you fill your numbers in, you'll notice that it's distance that we're actually looking for now, up here. What do you do when that happens? Well, it kind of depends what math level you're in. If you understand algebra well enough, you can probably figure out that you're going to need to get d by itself, and to do that, you're going to have to multiply both sides of this equation by 2.5, which is what I did over here on the sides. You see how I multiplied both sides of my equation by 2.5? When you do that, the 2.5 on the right-hand side over here cancels with the 2.5 on the bottom, and then you just have to multiply 2.5 times 600, which is how I got 1,500 kilometers. This might not be something that you're very good at or that you have a lot of experience with, and there's more than one way to attack that problem. Another way of dealing with it would be if you switch the formula around before you started plugging your numbers in. So if you know, for example, that you need to find time, if you need to find distance, not time, because it says how far does the plane fly. So we know we need to find distance. So really what we need is a formula that has distance equals something. So if you are not a good algebra student or you haven't had algebra yet and it bothers you to rearrange formulas, then you can just memorize the formula in a different form. So the formula for distance is speed times time. And you can memorize that if you can't do it any other way. Okay, we're going to switch it up now, and instead of doing a speed problem, we're going to do an acceleration problem. For this, you need to know the acceleration formula, which you might have to look up if you don't remember it. Try it out, see if you can do it, and then come back and see what I did. Okay, here we go. So the acceleration formula is acceleration is equal to the change in velocity over time. That little triangle thing written here means the change in. It's delta, which is a Greek letter. And this came up in a previous tutorial. If you didn't watch that tutorial or you didn't pay close enough attention, you might have missed that fact. So what does the change in something mean? Well, it means you need to take the final velocity and subtract the initial velocity. In other words, your change in velocity is the difference between the velocity you're going at the end and the velocity you were going at the beginning. So I've written the formula two different ways, and you can use either one that you prefer. The change in velocity is in the first one, right here, just written as delta V. That's a little triangle doohickey, delta V. And then I wrote out what that means in the second formula. In both cases, we're going to divide by the time it takes. Because if you think about it, your average acceleration is how much your velocity changes over time. So I wrote in my numbers here. The ending speed was 26, or the ending velocity was 26 meters per second, and the starting was 10 meters per second. And it's really important that I know what my starting and ending are. I can't just subtract this the other way around because I'll get a negative number, and a negative number will give me a different answer. So I have to be careful about that. So I have to do my final has to go here. My initial goes there. Initial is a fancy word for starting. That's why your initials are the starting letters of your names. And then I divided by 2 seconds down on the bottom. That works out to 16 meters per second divided by 2 seconds, which comes out to be 8 number-wise, and the units become meters per second squared. You can look at this two ways. You can think of it as, okay, I know my answer is an acceleration, so it has to have those units, meters per second squared. Or you can look at the numbers that you got here, or the letters I should say, and realize that you have meters per second, and you can write these two things mean the same thing. Meters per second squared and meters per second are the same thing. So acceleration problems are a little more complicated than speed or velocity problems are. So you have a whole worksheet, actually 2 whole worksheets that are attached to this tutorial that we're going to work on in class and that you can look over now and start practicing and thinking about before you come to class. I recommend that you do them in pencil, especially the ones that I haven't gone over yet. I don't recommend that you just copy down exactly what I did. I recommend that you try and work through those problems again in your own mind the way that I did, and you can certainly check your work using this tutorial. We're going to be practicing all of this stuff in class, and I'll be adding some other stuff to it. So you want to make sure that you've processed this information to the best of your ability and that you're going to be ready to work on this stuff later in the week. See you guys in class.